Okay, welcome back to the second part of the tutorial. In the first part of the tutorial, we answered the three business questions. What was the first three business questions? What was the most popular genre in each decade? Who was the most popular listened to artist in each decade? And what was the average danceability score of most recommended songs in every decade? The dataset that we are using have been provided on the description button. Please click on it. If you are new to the channel, make sure you subscribe. If you are new to the video, watch the first part of this tutorial to understand what we are doing in the second part of the tutorial. So the second part of the tutorial is to answer the two last business questions. What was the average BPM score of the most recommended songs in every decade? So as I told you, it's very straightforward. We're going to use the group by function to return that. And let me create a heading for it so that people who want to use this code can understand what we are doing at every section. So we need to group by decade. That is our basis of analysis. And then do BPM and then aggregate using the Pandas aggregate function. And then we are passing a string, a list this time around again. We're going to count the number of songs in each decade and then just calculate the average danceability score, not danceability score, but rather the beats per minute score of each song. So you can see the values increased between the first, it was 111, 117, that is between 1950s and 1960s. And then it suddenly rises. So I think the tempo of music changed in 1970s to 1990s to very, very high BPMs. And then between 2000 and 2010, it also increased, it reduced, though it has increased compared to the 1950s and 1960s. So the reason why these are changing, that is now the domain for subject matter experts. Maybe the shift in the kind of music that people are playing in different areas has changed. So those can be the contributing factors. So we are unable to tell that. That is something why you need a subject matter expert in this kind of analytics to give you well-informed decision. Now, the last question is, and this I think is the most important question. Let me just copy it as it is. This should be a heading. Yes, what is the secret behind a popular song on online streaming platforms? So the popular column song is this column here called pop, and it's rated according to the percentage, which ranges from 0 to 9. Before we do anything, let us see the highest score that was achieved in that column. So we can basically know what was the highest score in all the decades. So I can do df, and let me just write down first. Let us know the highest popularity score for the whole data set, and then in each decade. So what was the most popular song, or what was the highest score for the songs, for all these songs? So I can do df and do pop, then just do max. That will tell me the highest popular score. So it's 94. I'll be curious on which song is this. So how about by decades? Let me just copy this, or I can do df group by decade, BPM. It's not BPM, but rather pop, which is the popularity score. Then I'm gonna do pass the list, so I'm gonna count and then obtain the max. And maybe I should also obtain the mean so that I can see the least popular song in each decade. Yeah, so in 1950, the highest score was 72, 1960, 82, 1970, 84, 1980, 83, 1990, 79, 2083, 2010, 94. So 2010 is the one that recorded the highest, or the most popular song. I don't know which song should be that. Please, can you write a link and post it on the comment to show me the most popular song, and then I will see if you are literally following this tutorial. Good. That doesn't answer our question. So to answer this question, we are going to perform correlation analysis to understand why, or see what is the secret or what contributes to popularity of a song. So let me just do that, write it as a documentation. So to answer this question, we are going to perform correlation analysis of the attributes of a song So in other words, we are going to perform the how each of these attributes relate to each other, assuming that they're relating linearly. So as I said in my previous video, or in my previous tutorial, is we can perform this using Pearson correlation analysis. So we can perform this using Pearson correlation So the Pearson correlation analysis allows us to relate two variables. So in other words, we can relate one variable to the other and see how they are related and how they affect each other. So in this sense, we have got the popularity score. So we can perform how does popularity score relates to the BPM of a song. And if there's a positive correlation, it doesn't necessarily mean that the BPM causes that popularity, but it tells you that there is a relationship between these two. And then when you do hypothesis testing, you can actually establish if this is something you can reject the hypothesis that you are proposing, or adopt a new hypothesis altogether. So the way Pearson correlation works is it calculates the correlation coefficient, and this correlation coefficient is reduced between -1 and 1. So if you have got a -1, it means there is a negative correlation between the two variables. In other words, an increase in one variable leads to a decrease in another variable. If there's a positive correlation, that is anything above 0, then it means the correlation is strong, and one item or one property leads to an increase in another property. So let me just sum that up. Correlation analysis is performed is determined by Pearson correlation coefficient that ranges from -1 to +1. And let me just highlight this so that it's bold. And for clarity, let me break down how to interpret them. A correlation coefficient of -1 indicates a perfect negative correlation where the variables move in opposite directions with a strong linear relation. So for example, in maybe if you compare how a car is traveling along the road with time, as time increases, so there will be a very negative correlation between the speed and the time taken for that car to travel from point A to point B. So if a car is traveling from point A to point B, if you increase the speed, the time that is going to take will gonna reduce significantly, assuming that the speed is constant. And that is a perfect case of a negative correlation between speed and the time taken to travel from point A to point B. In other words, one variable leads to a decrease in another variable, and that is negative correlation. Positive correlation, so a correlation coefficient of 0 indicates no linear relationship between the variables. So it means they are uncorrelated. So if you take the example of the car, if there is no correlation between the distance and the time travel, between any correlation between the speed and maybe the name of the place. So it doesn't matter whether the place is New York, the place is DC, it doesn't matter. As long as the speed and the distance or the time is the same, there's no correlation between the name of the place and the speed or the time travel between those fixed points. The third one, a correlation coefficient. So this is the Pearson correlation coefficient of +1 indicates a perfect positive correlation where the variables move in the same direction with a strong linear relationship. So in the case of the car, if the car is not moving between fixed points and is just traveling continuously on a road, then there will be a very strong correlation between the distance covered and the speed of the car. In other words, if the speed is increasing, more distance will be covered. If the speed is reducing, less distance will be covered. That is a perfect case of a positive correlation. So this one will get us started. And to interpret this correlation, let me give you a range of values here. So the correlation of 0 to 0.1 shows no correlation. This is just a rule of thumb. 0.1 to 0.3 is low correlation. So remember, I'm just giving positive values. The same is true for the negative values. So 0.3 to 0.5, there's medium correlation, and 0.5 to 0.7, there's high correlation, and lastly 0.7 to 1, there is a very high correlation. So these values will act as a guidance. In other words, even if it's negative 0.1 to negative 0.3, still low correlation, negative 0.3 to negative 0.5, medium correlation, like that until the last one. But to perform this, especially if you want to test for a hypothesis, maybe you want to test for a hypothesis that the top genre has got a direct impact on the popularity of the song, then you have to ensure that your data is normally distributed. In other words, the popularity scores should be normally distributed. Very few people are submitting low popularity scores, and very few people are also submitting very high popularity scores. So that is the case. That might not be true for a small set or data set. It's good to have a huge data set to truly do that. So first, let us ensure that our data set is normally distributed. So let me write that. Spelling is distributed. So we can check for normal distribution using a histogram. Sorry for my bad spelling. And that can be easily done using Seaborn function, this plot. So SNS Seaborn, and then use this plot function. And we are interested in the popularity score, pop. Set this to true, and then group them into 7. So I'm gonna have 7 bins, 9, sorry. So you can see our data set is having some kind of a bell shape, but is negatively skewed, meaning more values are biased toward the high scores. But nevertheless, this is a small data set. If we had got more than maybe 667 data points as we have currently, then probably it would be a perfect normal distribution bell curve. So with that in mind, let's assume that it's normally distributed and perform correlation analysis. And to do that, first of all, let us drop the columns that we don't need. So we clearly don't need year and decade, as well as the title. So let me just check which columns do I have. Okay, so we have got so many columns that we really don't need. For the non-numerical columns, you don't even need to drop them because automatically they'll not be displayed in a correlation graph. So let me drop the numerical ones that are not necessarily like the year. So drop. Since I'm dropping multiple column, I'm gonna pass a list. So it's gonna be year. And then I'm gonna also drop the decade. And I'm gonna reset the axis to 1. So now that I've dropped that, okay, this should be now I can use the Seaborn correlation function to calculate the Pearson correlation coefficient of each of these variables. But before that, let me set the figure where I'm going to plot it. So PLT using this matplotlib. Then fig size, let me use 10 by 6. Then SNS. So I'm gonna use the heat map and then just do a correlation of the whole data frame. Cool. And annotate it. Set annotation to true. And then color map. I'm gonna use yellow because it's my favorite. Green and blue. Then run it. I'm having an error. Okay, so I'll specify the color that doesn't exist. I think it has to be on my GNBU. Oh, it should be capital B. So that should work now. Yes. So we have got a correlation table. Now, our interest is on the popularity of the song, and that is where we need to focus our energy on. So if you look at the popularity of the song, we have got different values, 0.19. You come to our table here, 0.19 falls between 0 and 0.1. So there's no correlation. We are not interested in that. The correlation of the property popularity with the acoustics is a negative 0.5. So let's look at the value. So it falls between medium correlation. So that is of our interest. So we can say there is a medium correlation between the popularity of the song and the acousticness. This stands at negative 0.05 to round it up. And what does this tell us? So it tells us, because it's a negative correlation, so one element is leading to a decrease. An increase in one element is leading to a decrease in another element. So in other words, if acousticity of the song increases, the popularity drops. So that should tell you that if you're producing a music, then you want to keep the acousticity as low as possible so that you don't drop your popularity. So we can say the I'm trying to, let me look for the right spelling so that I'm sure I'm writing the right thing. The acousticness of the song, of a song, or let's say songs with high acoustic value have low popularity score. Therefore, the involved parties should lower the acoustic value of their songs. Okay, now the question is, how do you lower that, or how do you ensure that? But how? Remember, as a data scientist, you are supposed to look into the data and provide solutions or recommendations to the business or to the research group. But how do you achieve this? The answer is, we do that by taking a detailed look at the correlation between acoustic value and other variables. Okay, so we are attempting to answer and provide solutions to this person. So now that we have realized that acousticity of the song is inversely related or is negatively correlated to popularity, so we want to keep it as low as possible. But how do we do that? We do that by taking a keen look at the relationship or the correlation between acousticity and the other songs. So let's come to this column where we have got the acoustics and look at significant correlation coefficient values. So the first one is negative 0.46. Already we have done that. That is its relation to popularity. We have got negative 0.17. That one is within 0.0 to 0.1, so no much interest. The next one is 0.23, negative 0.23. It falls between low correlation, so not of that interest. The next one is 0.2 same. Other one is negative 0.05, no interest at all. The next one is decibels. So this one is really, really interesting because it's a very medium correlation. So what's the relationship between the acousticity and the dB? It's a negative correlation. In other words, if acousticity increases, the decibels reduces, and if decibels increases, acousticity reduces. So what we need to do here, if you want to keep acousticity low, then we need to increase the decibels. So the first thing that we need to do is say there is a negative correlation between acoustics and there's a negative correlation of negative 0.5 between acoustics and loudness of a song. Therefore, to reduce acousticness and increase popularity, the loudness of a song should be reduced. So it goes to saying that one of the key things to consider is loudness of a song measured in decibels. That is one. Interesting. That is one. Okay, let's come back. So that's negative 0.5. Danceability is a negative 0.38. So let's look at our list and see where negative 3 or negative 0.4. So that falls between 0.3 and 0.5. So we can take that. Say let's just copy this. There's a negative correlation of negative 0.4 between acousticsness and danceability of a song. Therefore, to reduce acousticsness and increase popularity, the danceability of a song should be increased because they are negatively correlated. The danceability of the song should be increased actually. Because if danceability increases, the acousticsness reduces. The same goes to, there's a negative correlation between loudness. Therefore, if you want to increase popularity, you have to reduce acousticsness and then you have to increase the loudness. So this one should be increased. Sorry about that, I misjudged that. It can be confusing. So now the second key takeaway point is danceability of a song. And then lastly, let's take a look again. We have got a very strong correlation here of energy of the song and the acousticsness. So there's a very, if you look at our scale here, it's between 0.7, it's 0.5 and 0.7. So there's a high correlation. So you can say there's a high correlation between a correlation of negative 0.7. You can say high negative correlation of 0.7. Let me just copy this again. This is me being lazy. And energy of a song. Therefore, to reduce acousticsness and increase popularity, the energy of a song should be increased. I don't know how they measure these metrics in music. If you have got any music expert, please post it on the comment section. Energy of the song. So in other words, to go back to our research question, what is the secret behind a popular song on an online streaming platforms? So the secret is, first of all, you need to keep the loudness of the song relatively high. You have to make sure that the song is danceable. And then lastly, you have to increase the energy of the song. If you do these three things, they're going to reduce the acousticity of the song. And when the acousticity of the song reduces, the popularity will increase according to this data set. Whether this is entirely true, I don't own that. I don't know that. But the data that we have shows us that that is true. So if you can get more data, then probably what you have come up with might hold truth, or it might be debunked. So please, let's try and get those data out there. If you have got more music data, please share with me, and we can kind of try to understand what's going here. So once again, we started with working with this data, trying to make sure that it's in a form that it can answer the business questions. And now we have successfully answered all those questions in this tutorial. So if you have got any comment, please leave it on the comment section. If you have done what I've asked you to do, please share in the comment section. And any question regarding this, I will really appreciate if you can post it in the comment section. The data set has been provided. Please feel free to do more stuff with it. This is just something that I could do. Try coming up with the new research or business question that you can answer with this data set. And if you have not subscribed, please feel free to subscribe. I'm going to post this tutorial online to ensure that at least you can follow it alongside your video that you are watching. So until next time, if you like the video, give it a thumbs up, share with friends. Next time we'll have another interesting data science project for a different thematic area. For now, bye bye.